Okay, welcome to Chapter 6. This is our last official chapter chapter in AB. So today we're going to talk about differential equations. Now, as most of you know, there's a whole math course on differential equations, but this will just kind of whet your appetite. So a differential equation is any equation that contains an unknown function and some of its derivatives. The good news is that you already know how to do this. It's just written in a different form. You can have, when you're solving a differential equation, there are two types to solve. One is a general solution and one is the particular solution. The general solution has C in it. And the particular solution, you are given an initial condition and then you solve for C. So we're going to look at a couple of those. So here are the steps for solving a differential equation. The first thing you want to do is you want to separate the x and the y variables. What you want to remember is that dy and dx are always in the numerator. dy and dx are always in the numerator. Then you're going to integrate both sides, remember c, and then you're going to use the initial value to solve for c. If it's a particular solution, then you have to solve for c. Okay, so I'm going to give you an example. This one is a particular solution because you're given an initial value. So dy dx, we're going to separate dy dx. All of the x's are going to go on the right. All of the y's are going to go on the left. But remember, dy and dx must, when we're done, has to be in the numerator. So to separate the variables, dy, I'm going to multiply both sides by dx. So I get dy xy squared is dx. Okay, so what's wrong with this? I still have a y squared, so let's divide by y squared. In the future, I will do all of this in one step. I'm just doing it in a couple of steps just for effect, if you will. So now I have dy over y squared is equal to x dx. So I've separated my variables. I have all the y's on one side, all the x's on one side, and to find y, I integrate the function. So to integrating dy over y squared, remember we can write that as y to the negative 2. So writing y to the negative 2, to integrate that, I add 1 to both sides, so I get y to the negative 1. And then I'm going to divide by negative 1. And that's going to equal to x squared over 2 plus c. Now you may be asking, why don't I write c on the left side? Well, you can. You can write c, so we can have c1 over here and c2 over here. But when I combine those c's, I get a constant. So I just say it's one constant, and we generally write it on with the x variable. So now, what I suggest to students is that if it's a particular solution, you stop at this point and solve for c. Don't go any further, stop here and solve for c. So I'm going to take the value that I have, x is 0 and y is 1. So I get c is equal to negative 1. So now I have to solve for y. I can't leave y like this, I have to solve for it. So I can write this as negative 1 over y is equal to x squared over 2 minus 1. Now how do I solve for y in this? Well, y is in the denominator, so I can just invert both of these. So I can write it as negative y is equal to 1 over x squared over 2 minus 1. I can do that. Dividing both sides by negative 1, I can then write y is equal to negative 1 x squared over 2 minus 1. And you might be thinking, well, that's a little ugly and it's a little convoluted. Okay, well, let's clean it up a little bit. We can use Boldinism, and we can get negative 1 over x squared minus 2 over 2. Which then gives us y is equal to, multiplied by the reciprocal, negative 2 over x squared minus 2. And that's probably the way that I would prefer to write that and see that written. And it's probably what you'd see on a multiple choice test. Okay, once again, we're going to separate our variables, so all the x's are going on one side and all the y's are going on one side. This time I'm going to do it in one step. So I have dy divided by y is equal to 2x dx. Now dy and dx always have to be in the numerator. You have to remember that. Dy and dx always are in the numerator. And then I integrate both sides. So the integral of dy is the natural log of y is equal to x squared plus c. So once again, I stop at this moment and I solve for c if it's a particular solution. So I get the natural log of y, of 1, is equal to 0 plus c. Well, the natural log of 1 is 0. So c is equal to 0. Now, let me just say this, even though you may have looked at that and realized that c was equal to 0 immediately, on a free response question, you have to show that you solved for c. You have to show that you considered c. Generally, if you don't consider c, then you lose like 5 out of the 9 points, okay? So you have to show that you at least considered c, even if it's 0. Okay, so now going back, now I have the natural log of y is equal to x squared. How do I solve for y? I exponentiate both sides, so I get e to the x squared is equal to y. Now this is a general solution. So in a general solution, there is no c. There's no initial, there is a c. There is no initial condition, and your final answer will have c in it. So once again, I have to separate my variables. So I don't have any other y's, so I just have dy here. And then I have e to the x over e to the x plus 1 dx. So once again, I have to integrate both sides. The integral of dy is simply y. The integral of this, I'm going to have to use the u substitution. So if I let u equal to ex plus 1, then du is equal to e to the x dx. And since that is in my problem, I'm golden. So now I have the integral of u, I'm sorry, that's not right. Somebody stop me. I have the integral of du over u. Sorry. Okay. So the integral of du over u is going to equal to y is equal to the natural log of u. Well, the natural log of u is e to the x plus 1 plus c. And really, that's all I can do with that. I have y, I've isolated y, and I have c in my answer, and I can't go any further with that. Okay? So here's another one. It's a general solution because we don't have an initial condition, and my variables are already separated. So I have to move the x to the other side. So I have dy is equal to x cosine of x squared dx. So I'm going to integrate both sides. Once again, I'm going to have to use u substitution. So u is equal to x squared. Du is equal to 2x dx. So 1/2 du is equal to x dx. And I have x dx in my original problem. So I'm integrating 1/2 cosine of u du, which gives me 1/2 cosine of u. Integral cosine of u is sine u, and u in this case is x squared plus c. I'm done. Easy peasy. Okay, once again, we have to separate our variables, and what I want you to remember is dy and dx always have to be in the numerator. dy and dx are always in the numerator. So I'm going to rewrite this as dy. I'm going to divide both sides by y plus 1, so I have y plus 1, and that's going to equal to 2x plus 1 dx. And again, I integrate both sides. Now, I could use the u substitution for this, but at this point in your career, you should also be able to look at that and know that that's going to be the natural log of y plus 1. And integrating this, I get x squared plus x plus c. Okay, so now I need to solve for y. So I do e to the x squared plus x plus c is equal to y plus 1. I want to stop here for a second because we're going to do something in a couple of days when we do growth and decay that's going to require that you understand something. So I might as well introduce it to you now. So what I want you to see here is that this can be written as e to the x squared plus x times e to the c. Because remember, if we have the same base, we can add exponents. So if I have the same base, if I write this with the same base, then I'm just adding exponents here. So I can rewrite this way. So you may be asking, why do I want to do that? Because e to the c becomes its own constant. So now I can write that, instead of writing this as e to the c, I can write it as some constant, and let's call that constant k. So now I have k, e to the x squared plus x, and that's equal to y plus 1. So y is equal to k, e to the x squared plus x minus 1. And you're probably asking, why didn't I do the same thing with e to the x? Well, I could have written this as e to the x squared times e to the x, but that really didn't buy me anything since e to the x is still a variable. I'm sorry, yeah, it's still a variable, still an unknown. Okay. So once again, we're going to do this problem, and we're going to separate our variables. So we have dy is equal to x plus 1 over x quantity squared dx. Integrate both sides. Yeah, that looks a little complicated. So what should I do with that? Well, I can't really use the u substitution. So you know what I'm going to have to do? I'm going to have to multiply this bad boy out. So that gives me x squared. X times 1 over x is 1. So I multiply that times 2. I get 2. And then this becomes 1 over x squared. And then I integrate. So that becomes 1/3 x cubed plus 2x. That's going to be x to the negative 2, which gives me x to the negative 1. And it's going to be negative plus c. And I'm done. Okay. So that's it for separating variables. I think you have some homework to do in your book. As you can see, it's relatively easy, and it's just a review of integration. So try differential equations, and we're going to do more of these. We're going to do some more complicated ones tomorrow. Thank you.